In 2.7, we're going to talk about inverses, and we're starting out in this video with an introduction, and there's a couple ideas. Both of these ideas are presented in the textbook as well. But one idea is they're talking about movies, and they're talking about the movie and then the number of Academy Awards. Let's put AA for Academy Awards. And so it's this relationship, like an ordered pair. So they mentioned the movie Ben-Hur, the Titanic, and The Lord of the Rings. Okay. Oh, and West Side Story. Okay, so I'm just abbreviating so I don't have to write them all out. And they say Ben-Hur, well, they got 11 Academy Awards. This is in, I think, 1960. The Titanic, I don't remember when that movie came out, but it got 11 Academy Awards. And The Lord of the Rings, it got 11 Academy Awards. West Side Story, by the way, that's the 1960 version, or 61, I think. Got 10 Academy Awards. So there's this relationship here, right? Like we can make this into ordered pairs. There's the mapping, and we've done this before. And we can make little ordered pairs. You know, I'm just abbreviating things in the interest of time and space. The Lord of the Rings. Okay. And then West Side Story. Okay, so we have 4 ordered pairs. We have this set here. The inverse is when we're going to go the other way. We're going to map the number of Academy Awards to the movie. So the inverse of this relation would look like this. 11, Ben-Hur. Titanic. Oops, I'm sorry. No, 11, Titanic. I got to go the other way. Okay. So 11, Titanic, 11, and The Lord of the Rings, and West Side Story. Nope, did it again. That's what I get for not looking at it. 10, West Side Story. Okay. And then that's a new relation, right? Okay, so it's like the X and Y have switched places, right? That's what's happening in an inverse. Okay, you're mapping the other way. So there might be times when you want to look up a movie, you know, and see how many Academy Awards it got. But then there might be times when you want to say, well, how many got 11 Academy Awards? Or how many got 10, or which movies got 10 Academy Awards, or something like that. So it depends on the input and the output, right? Okay, so that's one idea. Now let's say, we'll go to another idea. Let's say you have a computer store. So you're selling computers, and you get computers at wholesale price. And then you say, okay, every computer I get at wholesale, I'm going to mark it up $300. Okay, and that's how you figure out your prices. You could make this a function, right? You could say, okay, there's the function, and that's what I'm going to do. I buy a computer for $800, I mark it up $300, so I'm going to sell it for, you know, $1,100. You could do that with all your computers, right? A little formula there. But then let's say you have another function where you say, hey, I want to give a discount. Every computer we sell, we are going to mark off $300. So whatever our sale price is, we're going to take off $300. Okay? Now, that would be a different function. But what if we put the two functions together? So we buy something at wholesale. This should have been a W, huh? Okay, W, I buy it at wholesale, and I mark it up $300, but then I take off $300, then I'm back to that wholesale price, right? Okay, so this is another concept in inverses. You do something, you know, to a number, and then you undo it. Okay? All right. So those are just some, you know, kind of very vague examples of what we're talking about with inverses. Okay? And it gets us started with what we're going to be doing here. We do have notation. So if we have a function x, its inverse looks like this. F inverse of x. Okay, that is the inverse notation. Inverse notation. It's not an exponent. It looks like an exponent, but it is a superscript, but it's not an exponent. It's representing the inverse of the function f. So when we talk about functions and their inverses, we're talking about two things. We have the function, the original function, and then we have its inverse. Okay? Yeah. All right. So the definition of an inverse says if you compose the function with its inverse, then that's just going to equal x. And it also has to work the other way. If you take the inverse and compose it with the function, that has to equal x. So we have examples of this where, you say, tell me your age, and add 3 and multiply by 2, and then, tell me what number you get. And then the person can figure out the other person's age because they can do the inverse, right? Okay, so they can, divide by 2 and then subtract whatever I said. Anyway, that's the idea, though, of inverses. You're doing something and then you're undoing it, okay? Okay, we're going to talk about domain and range in the next video.